This is lesson 4.2, and you can see here I've already set up the first problem. This information was in a two-way table, and we made a matrix out of it. That's the same thing that we did in last lesson, making matrices out of data. And so what we have here is we have the verbal and the math scores for SATs for males and females from 1995 through 1998. And what we want to do is create another matrix that has their total SAT score. Total SAT. Alright, so what we're going to do is we're going to add these two matrices together. And the way that you add matrices is you add each individual element. So this is the element 1, 1. It's in row 1, column 1. And we're going to add it to element 1, 1 of the other matrix. So 505 plus 525. That will be our first element. And 505 plus 525 is 1030. So our first element is 1030. Okay, now I'm going to just not go in order this time. The next one would be you add this one, element row 1, column 2, so element 1, 2 with element 1, 2. You would add those two together and you get 1010. Okay, so I want you to go ahead and pause the video and try and solve the rest of this and see what you end up getting. Okay, so if you added them together, you should get a matrix that looks like this. Total SAT score. Now we're not quite done. I need to label this. This column is, this row is male, this row is female. This is the year 95. This is 96, 97, 98. So we have the same columns, the same rows, but now we've added the data together in the table, and this is what you should get. So that's how you add matrices. It's pretty straightforward. It's what you might think you would do. Multiplying matrices is a bit different, but adding matrices is pretty straightforward. I'm going to do this problem in the extra help video. Okay, so this matrix right here is called the identity matrix. The identity for addition. And the reason why it's called the identity of addition is because when you add these two matrices together, let's go ahead and do that. If we add every single element 1, 1 with element 1, 1, element 1, 2 with element 1, 2, element 2, 1 with element 2, 1, and element 2, 2 with element 2, 2. What we get is the matrix that we started with. Okay, so that's what the identity means. It means if you add the identity for addition, it means it doesn't change anything. So the identity in addition for just regular real numbers is 0. 2 plus 0 is 2. Anything plus 0, a plus 0 is a. That makes it the identity of addition. Okay, and then related to that concept is called the inverse. Inverse for addition. Okay, what an inverse means is when you say this is matrix A and this is matrix B, okay, then when you add them two together, if you add these two matrices together, you get the identity for addition. And that means they are opposite matrices or additive inverses. Okay, so let's go ahead and add these two together and see if they are inverses. 2 plus negative 2 gives you 0. 8 plus negative 8 gives you 0. Negative 3 plus 3 gives you 0. And 0 plus 0 gives you 0. Okay, so each individual element, element 1, 1, and element 1, 1 over here, that's 2 plus negative 2. These numbers, in real numbers, are opposites of each other. They're additive inverses. If that's true for every element, 8 and negative 8, negative 3 and 3, 0 and 0, all of these are additive inverses of each other, and so the entire thing is the additive inverse. Okay, now we're going to move to matrix subtraction. So matrix subtraction is just like addition, except first you multiply all of them by negative 1. So there's two ways we can do this. I could say 3 minus 1. Let me go ahead and write my product. Not product, my sum over here. So 3 So I'm trying to find a minus b. 3 minus 1 gives me 2. Another way to think about that is I could say 3 plus negative 1. So I could multiply all of these by negative 1, or just change the sign on them, and then I could add them. 3 plus negative 1 gives me 2. 2 plus negative 4 gives me negative 2. 4 plus negative 3 gives me 1. Negative 1 plus 2 is 1. 4 plus negative 2 is 2. 0 plus negative 4 is negative 4. Okay, so that's the technical definition. You multiply all of these things by negative 1 and then you add them together. You could do that by just doing subtraction also. Okay, if I didn't do that, I could say 3 minus 1 gives me 2. 2 minus 4 gives me negative 2. 4 minus 3, 1, and so forth. Okay, so that's matrix subtraction. Again, it's what you might think you would do. When we get to matrix multiplication, it's going to be very different, but addition and subtraction is almost exactly what you might expect. So let's go ahead and use this knowledge and to solve for this matrix. This capital variable letter stands for a matrix. It means this is not just one number, it's an entire matrix. So if we have some matrix minus another matrix is equal to a third matrix, we can figure out what this unknown matrix is by doing what you might expect. So I'm just going to use letters. X minus a equals b. We'll call this matrix A and this matrix B. To solve for x, if I add a to both sides, then I get x is equal to a plus b. And that's what you might expect to see. So if I add these two matrices, sorry, not matrices, matrices. If I add these two together, then I'll find that unknown matrix. That's what we've done here. Okay, so I'm going to add this matrix to both sides. 1, 1, 3, 2 is equal to, if I add it over here also. Okay, when I add these two together, they're opposites of each other, and so they cancel out. It gives me the identity, which I don't need to write because x plus the identity for addition is going to be just x. And then here, if I add 0 and 1 together, I get 1. If I add 1 and 1, I get 2. 8 and 3 gives me 11. 9 and 2 gives me 11. So this unknown matrix X is the matrix 1, 2, 11, 11. Okay, this one I'm going to do in the extra help video if you need extra help. And then the last type of problem that we're going to look at today is equal matrices. So when you set two matrices equal, that means every single individual element is equal. So for example, 1/2, -3, 0.75, 2/3. Okay, this is a point. 0.5 minus 6/2, 3/4, and 0.6 repeating. These are equal matrices because this element 1, 1 equals element 1, 1. Element 1, 2 equals 1, 2, and so forth. Now, if I hadn't written 0.6 repeating, let's say I had rounded here, and I wrote 0.67, these are no longer equal matrices. They're not the exact same. These three elements are the exact same, but these two are not. 2/3 does not equal 0.67. 2/3 equals 0.6666666. I could keep writing this forever, right? So this is an approximation of 2/3, but they are not equal, so these are not equal matrices. Okay, so how that works in a problem like this, I would want to solve this problem to figure out what x and y are. And the way I do that is this element, element 1, 1, should equal element 1, 1 over here. So that means 2x minus 5 is the same thing as 25. I don't know what x is, but I could figure that out now. Let's add 5 to both sides. And 2x is equal to 30, so x equals 15. Okay, if I plug 15 in here, I get 30 minus 5 is 25. The elements are the same. 4 and 4 are already the same. 3 and 3 are already the same. Here, 3y plus 12 is going to be the same as this element, y plus 18. So now I can solve this equation for y, and I can make these two equal matrices if I set x equal to 15 and y equal to whatever it comes out to be. So let's go ahead and do that. Solve for y. I get 3y equals y plus 6. Now I'm going to subtract y from both sides, and I get 2y equals 6. So that tells me that y is equal to 3 if I divide both sides by 2. So since these two matrices are equal to each other, they're set equal, that means x must be 15 and y must be 3. And I believe that's it for this lesson. Yeah, I'm going to do that one in extra help.